In LCM and HCF, we will start with the prime factorization. First thing. Second is how to find HCF, how to find LCM, LCM and HCF of fractions. And another thing is, if I'm taking any two numbers, their product will be equal to product of their LCM and HCF. We'll understand this also. Let us discuss prime factorization. I'll take a number 6, another number is 12, another number is 18. So, what will be the prime factorization of 6? I can write this as 2 into 3. 2 raised to power 1, 3 raised to power 1. 12 can be written as 4 into 3. 18 can be written as 6 into 3. So, further if I write, this will become 2 raised to power 1, 3 raised to power 1. This will become 2 square into 3 raised to power 1. This will become 2 into 3 into 3, which ultimately will have 2 raised to power 1, 3 raised to power 1, 2 square into 3 raised to power 1, 2 raised to power 1 into 3 square. So this is the prime factorization for these three numbers. Now, why we are learning this just before LCM and HCF? Because we will solve the HCF and LCM by using the prime factorization. Now we will discuss what is HCF, the second topic that was mentioned. So HCF is highest common factor. Let us say we'll take example of 2, 4 and 8. What will be the highest common factor of 2, 4 and 8? We'll write this is 2 raised to power 1, as we already mentioned that we will write the prime factorization. So this is 2 square, this is 2 cube. So for HCF, what we have to do, we'll take lowest power, which is common. So from here we can easily observe 2 is common. It is common in all the numbers 2, 4 and 8, and which is the lowest power for 2 that is common, we can say 1. So highest common factor of these three numbers is 2. Let us take another example. To understand HCF, I'll take two numbers now. So 12 and 21. We'll take the highest common factor of 12 and 21. So 12 can be written as 2 square into 3, where we can say 21 is 7 into 3 or 3 into 7, right? So what is the common thing here that is visible in the prime factorization? We can say the common part here is 2 is common? No. 7 is common? No. But 3 is common with the 1 power. So I would say the HCF of 21 and 12, it is 3 raised to power 1, that is 3. So this is the method we will use to solve the questions to take HCF. Now let us discuss LCM, the third subtopic. So what is LCM? LCM is least common multiple. So if I take example, the same example I'm taking 2, 4 and 8. Let us find the LCM of 2, 4 and 8. So we can write this as 2 raised to power 1. This is 2 square, 2 cube. In the case of LCM, we have to take highest power of every prime factor. So in this case, we have only one prime factor, that is 2. So 2's highest power is 3. So I can say LCM of these three numbers is 8. Basically, we can say in this case, if I multiply 2 with 4, we'll have 8. 4 into 2 is 8. 8 into 1 is 8. So least common multiple of these three numbers is 8. Let us understand least common multiple by taking one example here. I'll take the LCM of 12 18 and 32. So here we will take the prime factors of 12, that are 2 square into 3 raised to power 1, because it is 4 into 3 12. 18 is 2 into 3 square, that means 2 into 9. 32 is 2 raised to power 5, that is 32. So as I said, that we have to take highest power of each and every prime factor. So we will write 2, we have 2 and 3 as the prime factors. What is the highest power of 2 that is visible here? We will write 5 into what is the highest power of 3 present here, that is 2. So actually it becomes 32 into 9. So 32 into 9 will be 288, that is the LCM of these three numbers. Now fourth is we will find LCM and HCF of fractions. For example, if I say 1 by 2, 3 by 5 and 7 by, let us take 11. I have to find the LCM of these three given fractions. First fraction we have 1 by 2, second we have 3 by 5 and third we have 7 by 11. So for LCM, what we will write? We'll take the LCM of numerators divided by HCF of denominators. So for this example, if I take the LCM of 1, 3 and 7, we know there is nothing common. So LCM will be 7 into 3, 21. What about the HCF of 2, 5 and 11? Again, we don't have any common factor here. So I can say HCF will be 1 because nothing is common. So what will be the overall LCM as the fraction? So we know the LCM of numerators is 21, HCF of denominator is 1, so answer will be 21. Solve HCF of the given fractions. So we have 1 by 2, 3 by 5 and 7 by 11, right? So for HCF, we will take HCF of numerator divided by LCM of denominators, right? So let us take the HCF of 1, 3 and 7. As we know, 1, 3 and 7, there is nothing common. We don't have any common factor over here. So HCF will be 1. What about the HCF of LCM of 2, 5 and 11? Again, nothing is common. So I'll write the LCM of 2, 5 and 11. It will be 2 into 5 into 11. That is 110. 2 into 5, 10 into 11, 110. So HCF is 1 and LCM of denominator is 110. So our answer of this HCF, if I have to find the HCF of 1 by 2, 3 by 5, 7 by 11, I have taken HCF of numerator divided by LCM of denominator. So 1 by 1, 110 is the HCF of this. Let us discuss the last type, that is LCM and HCF's product is equal to product of any two numbers. So I'll write it once, product of any two numbers should be equal to product of their LCM and HCF. Let us understand this with one example. If I say I have the number 2 and 3. 2 and 3 are the two numbers we have. What is the LCM of these two numbers? It will be 2 into 3, 6. What is the HCF of these two numbers? That is 1 because nothing common. So if I multiply the LCM and HCF, that is 6 into 1. This is LCM, this is HCF, it is 1, 6, right? And if I take the product of these two numbers, product of 2 and 3 is also 6. Let us discuss the fifth point with one example. Example is already given here. LCM of two numbers is 60 and their HCF is 3. Find the second number if first number is 12. We know product of any two numbers is equal to product of their LCM and HCF. So I'll write product of the LCM and HCF. So this is the LCM, this is HCF. Product is 180. Now this product should be equal to product of the numbers. We have already given with first number, that is 12. Second number is x. So I would say x equal to 180 by 12. So value of x will be 15. So this is the solution to this particular example. From here we understood that how to solve this kind of the question if they're giving us the one number and LCM and HCF is given to us.